Alright, so this is a workshop on the HR diagram. We're going to take some notes at the bottom first, and then we're going to return to the diagram and elaborate on it as well. So first of all, as you should already know, the HR diagram classifies stars based upon two factors. What are those two factors? Well, if you said color or surface temperature of the star, you're correct. So color corresponds directly to surface temperature of the star. And it also classifies stars based upon their brightness, was sometimes referred to as magnitude, and sometimes it's referred to as luminosity. So just be aware that all three of those words can be used interchangeably. So what information can you get from the HR diagram? So let's write that down. Information you can get from HR diagram. Okay, so you can get information on the color of the star. You can get information about the temperature of the star, because remember, temperature and color already are one and the same thing. They're totally correlated. So temperature of star. You can also get the approximate size of the star. You can get the approximate age. And you can get, of course, the brightness or the luminosity. Okay, what can you not get by utilizing the HR diagram? Well, you cannot find out where to look for it in the sky, so you cannot get location in sky. And you also cannot get how far the distance is from our planet or our solar system. So you cannot get distance from us. Okay, so when we talk about the approximate age, any star that falls along what is known as the main sequence, if you look up here at the diagram, this whole area here is what is known as the main sequence. These are all stars that are living. You'd find our sun here, for example, because these stars are all living. They have not begun to use up all their hydrogen. Remember, they do hydrogen fusion. So once they use up all their hydrogen, they will no longer be able to live. They'll fuse elements into heavier and heavier elements. And once that's done, basically, they start to die. And we're going to talk about how that relates to this diagram as well. So, main sequence stars are living stars. Okay? Remember we talked about the life cycle of the star, and we said that as our star, the sun, ages in about 4.5 billion years, our sun will expand to become a red giant. Well, our sun will expand to become one of these, a giant, okay? Supergiants, on the other hand, are those large stars like from large to triple XL. Remember, they're sequence was to go into red supergiant, and then they were going to supernova explode. So here are supergiants. So obviously giants are bigger than main sequence stars, and supergiants are the biggest stars out there because of their expansion. Now, once our sun has completed its expansion, it will shrink to the size of a white dwarf. And here we see white dwarfs are down here at the bottom. These are very, very small stars, right? These are dead stars. They just have enough energy to glow a little bit of light, but that's all they have. They're very cool, and well, they're not really, really cool, but they're very, very dim. They're not as bright anymore. All right, so that kind of shows us that depending on the star's age, it kind of would fall on a different place on this diagram. Now, like I said, you can't look up at the night sky and see the stars like this. This is not how they are. This is the plotted stars on a diagram based on surface temperature and brightness. Okay? So let's look at the surface. Well, let's elaborate here for a minute. So our giants and supergiants are dying stars. And our white dwarfs are basically already dead. They're just cooling off. Remember, our sun will become a white dwarf, but then once it's totally cooled off and the light is all gone, the light energy, it will become a black dwarf, and you can't even see it anymore. You only know it's there because it pulls, has gravitational pull. So they're dead and cooling. Alright, so that's a little bit about the diagram. So now let's dissect this diagram. So as you already should know by watching the PowerPoint, the temperature increases from right to left in this diagram. So meaning that here on this side of the diagram, the stars are cooler, and we get increasingly warmer as we go in this direction. So we have cooler on this side. Anything on this side is cooler than anything as you go increasingly over here. So these would be the warmest, right? And then brightness, and we already know that it's sometimes called magnitude, but it's also sometimes called luminosity. So we're going to add that so we don't forget. Okay, so brightness increases as you go from the bottom of the diagram to the top. So any stars that are towards the bottom are going to be dimmer, meaning they have less light, and as you move up the diagram, they get increasingly warmer, brighter, 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 brighter. So we have the dimmest stars at the bottom. So they almost have no light, see, but they are relatively warm. And as you move this way, we have the brightest. Okay, so with this diagram, if you pay close attention, you're going to see that there's also some colors across the top. These colors have to do with the direct color of the star associated with its surface temperature. So if we look at a star and it is reddish in color, its surface temperature ranges about 3,000 degrees Kelvin. Kelvin is just another measure for temperature. So red stars are around 3,000 degrees Kelvin is our measure, okay? All right, so as we move further, the degrees or the temperature increases. So red-orange stars have a temperature of about 4,500 degrees. And then remember, we're going from cooler to warmer, so the cooler stars are here, getting warmer. Yellow stars range from around 5,500 degrees. I don't know what I wrote there. About 5,500 degrees Kelvin. And then as we increase to white, we're about at 10,000 degrees Kelvin. And then blue to blue-white, they range from anywhere from 20,000 degrees all the way to 40,000. So we can see that the temperature increased nicely as we went from the right side of the diagram towards the left. Temperature is also what is associated with what is known as spectral class, and these are just letters that correspond to the temperature. But I want you to have seen them just in case they pop up on one of the diagrams in the station lab. So M is for red, K is for red-orange, G is for yellow. So our star with sun is definitely a yellow star. F is for white. And then here we have the more whitish blue is going to be an A, all the way up to a B for the more blue-white, and then totally blue or totally hot star is an O. So just in case you see these letters, they correspond directly to color and temperature. Okay? So let's go ahead and outline this color with the temperature. So here are red. All of these stars in this area are red. So they're red in color. They're cooler. They have a surface temperature of about 3,000 degrees, and their spectral class is M. We look at dimmest to brightest. Remember, we still have to follow the dimmest are on the bottom side of the diagram, and they get increasingly brighter. That does not change their temperature. Alright, so our next one is red-orange, spectral class K. They range from around 4,500 degrees Kelvin. That includes all of these in this area. Okay? Everybody following this diagram? Yellow, our sun is a yellow star. It's right there, right in the middle of yellow, because all of these here in this diagram are the yellow ones, yellow stars. So our sun is right in the middle of the main sequence. It's a living star, and it's yellow in color, and we already know its size is medium. So here it's all coming together, I hope. The next stars are white, so I'm just going to kind of outline this one maybe in a gray, just to know that they're white. I don't know if that helped at all. Who knows? And then the next ones will be the blue, blue, white, and let's see, I'll do a lighter blue here, and then a darker blue towards the other spot, and the coldest, excuse me, the hottest stars are the blue stars. Okay, so I hope that helps kind of give you an idea of how this breaks down. Once again, things to note. Supergiants are bigger than giants. Giants are bigger than main sequence stars. White dwarfs are the smallest. This whole area is the area of supergiants. That's why it's kind of outlined. This whole area is the area of the giants. And this whole area is actually the area of the white dwarfs. And we had already outlined our main sequence or living stars. I think that about covers it. If you have any more questions, or if you want to review some more, there is another short PowerPoint on just specifying exactly how to read the diagram. All right. Thanks for watching.